Hey, how's it going everybody? And welcome back to Michael Workspace. I am Michael, and in today's lesson, we'll be going over another LeetCode problem called Maximum Subarrays. It is problem number 53 and is considered an easy problem. However, it is a very popular problem that is being asked by some of the biggest tech companies in the world. And we can take a look here to see some of these companies. And within the last 6 months, as you can see here, it's been asked by Amazon, Apple, Microsoft, Facebook, and Google, and many other companies that you probably recognize there. So it is a problem that you should kind of like commit to memory because you're probably going to run into it in the future. All right, so let's go ahead and take a look at the problem statement. It is called, oh, well, let's just read it. Given an integer array nums, find the contiguous subarrays containing at least one number, which has the largest sum, and return its sum. Okay, so they gave us an example here. Input array with the elements or the value of -2, 1, -3, 4, -1, 2, 1, -5, and 4. And within this array, the subarray that gives us the largest maximum value contiguously is 6, the total of 6, and it is this block of this block right here representing a subarray with the value of 4, -1, 2, and 1, and if you sum that up, it'll give us 6, and nowhere else in this entire array that we can break down to a subarray that will give us a larger output. All right, so yeah, I think we can go ahead and get started. Right off the bat, there's one very obvious solution, but it might not be the best solution, and that is doing a nested for loop to give us all the possible subarray outputs, and then we can do a max of the subarrays, and whichever output the max, the largest value for the max will be our answer. And yeah, this is not the ideal solutions, but I'll go ahead and code it up, and then I'll explain the time complexity of it, and then we can look for a better solutions. Okay, so let's go ahead and handle our edge case here, so that if the length of the array is 0, then we're just going to go ahead and return 0. And also, if all the value in the array is a positive integers, then the maximum, or then the output or the answer would just be the total or the sum of the entire array, because that will give us obviously the answer. And another edge case is that, which might not is not really expressed in the problem statement, but if you think about it, if the array consists of all negative numbers, then the output would just be the maximum of the maximum value within the subarray, because for example, if the array looks like something like this, 5 and 2, then the maximum value of this array, or the maximum element, just one single element, is -1, and that will be your answer. Okay, anyways, let's go ahead and begin here. So if length of our nums array equals 0, then we'll go ahead and return 0. All right, and then here we'll go ahead and initialize our beginning maxim with just whatever is the first value in the array. Indices 0. All right, and then we'll go ahead and construct our nested for loop here. J in range 1, and we'll go ahead and do length of nums plus 1. And the reason why we're doing length of nums plus 1 is because we're going to be using this j value to slice our subarrays, and we're doing a plus 1 here because when you do a slice in Python, the stopping the stopping slice value is exclusive to the return slice. So what that means is that if we have a slice of between indices 1 to 5, we actually only going to get back the values for 1, 2, 3, and 4, and not the fifth element. And that's why we're doing the +1 right here. All right, so within this, we're just going to be doing a setting the max value equal to the max of the max sum, and using the sum function, we're going to be calling that upon the slice between I through j, and yeah, that would, so whichever is larger would then update the max sum value, and at the very end we're going to go ahead and return the max sum value, and that should be our answer. Let's go ahead and run this code to see if it works. It's thinking. Yeah, it usually doesn't take this long. I'm not sure if it's... Oh geez, my internet has dropped. Let me check that real quickly here. Yeah, you think that would be a problem, right? Let's just make sure that this works. Gets connected to the internet here. And I'm getting connected back. Well, that's funny. Alright, so it's not executing, so I'm just going to go ahead and refresh this page, and hopefully I can just execute the code afterward. Alright, so I refresh the page, and I'm going to run this code, and hopefully it works. Oh, there you go. It got accepted, and let's go ahead and explain. Well, let's just, you know, as a best practice, you should, you know, actually enter in more like more test cases. So let's go ahead and do something like just random numbers here I'm throwing out. Alright, let's just try that. Okay, everything seems to be working, and you should probably add more test cases here to kind of hit all the edge cases, but I think you know, this is fine for now for this video. I'm going to go ahead and go back to the console and explain the time complexity and space analysis to this problem. Okay, so the time complexity of this is actually, well, we're doing a nested for loop, and within a nested for loop, we're calling the maximum function on each slice of the subarray, and this consists of a O of n linear time and operation, and if you add that to the nested for loops, this comes out with a total time complexity of O of n cubed. What am I doing? It's like that, which is very bad. It's slow, it's not good, and we'll come up with a better solution after this. Let's go ahead and talk about the space. Because we're not using any extra space in this algorithm, this is going to be an O of 1 constant time complexity. All right, so let's go ahead and think about how we can do this better. And right off the bat, maximum subarray. You know, this is a very famous problem, and there's a very famous algorithm that accompany this maximum subarrays and any like variation of this same type of problems out there. So you might, for our use case, for this particular case, we're just returning the sum of a maximum subarrays. But you know, in other websites or other interview problem, you might run into like a variation, like a different problem where they tweak it a little bit, and instead of returning the sum, you might return like the indices, or you might return, instead of maximum, they ask for the minimum subarrays, and you can tweak the problem that way by, instead of using max, use a min. But anyways, we apply something called Kadane's algorithm to this problem, and that will give us a much better time complexity, much quicker than what we had before. Alright, so to explain Kadane's algorithm, I think it'd be better if I open up something, like I'll open up Paint, and then I'll draw out kind of an example to better explain how it works. So I'm going to go ahead and just make this a black background, change this foreground to white, and let's go ahead and use the LeetCode input array here, for example. Alright, so, and I'm going to go ahead and use a brush here with a red color. Alright, so the way it works is that we start from left to right, and then and then we take a look at each indexes, all right, and each subarray that we can generate out of of the entire array. And for example, right now we're starting with a value of -2. Well, if you think about it logically, if we're trying to find a maximum subarray from from our array, we would never want to include this value here because it's a negative value. So we know that if we include this to any other subarray to get our sum, it would never be the answer, because you're just making your answer less by including the -2. So what we do is that we'll exclude that, not use it at all, and then we'll just go ahead and start at the next indices and check to see if it's a positive number. And in this case, it is 1. So we'll go ahead and accept that. We'll take that and add it to our current sum value, and we'll take and then we'll check to see what the next value is. It's -3. So then right now our current sum is 1, and if the largest of these two, the sum of these two indices value together, it would be -2. And we wouldn't want to include this into our as our final output, because why would we want to take in something that will give us a lesser value? So we'll go ahead and remove that, and then check to see what our next value is in our array, which is 4. We will definitely want to take that in and update our current sum value, and then check to see what the next one is -1. So if we include this here, we'll get a total of 3, which is still greater than 0. It's still a positive number. So we're going to go ahead and update. Well, our current sum would still be 4 because it's greater than greater than 3. But we want to check to see what else are we going to get afterward, and we're going to get 2. So if we take 2, add 2 to 3, we get 5, and 5 is larger than our current sum, the larger value so far. So we update that to be 5, and then we continue on, and then the next value is 1. So we obviously want to add that to update our current value to get 6. 5 plus 1 equals 6, and then we continue on, and then the next one is -5 to 6, and then obviously we'll get a difference of just 1 after that. So we go back to 1, and right now our largest value, our current sum value, is 6, and then we continue on. And if we go through our entire array and we end up getting a sum of like something that's less than 0, like a negative number, we're just going to go ahead and discard that and just reset it back to 0 and continue on with the next value in the array to see if we can come up with a sum that's greater than whatever we have for the current sum value. And yeah, that's how Kadane's algorithm works, and how we implement it in code will look like something like this. So I'm going to go ahead and just comment this bit of code out, continue on with our algorithms. I'll make a comment here for Kadane's. I think it spells like that. All right, so how it works is that we wanted to initialize our a value or a variable that stores a like an arbitrary like a unbounded negative value to begin with, and then we'll just keep adding to it as we step through or loop through our array, whatever value we get next. So the way we can do this or express it in Python is that we can express like a negative infinity number by doing something like this. Oops, can't type. All right, and this represents a negative infinity number. All right, and then we also want to initialize another variable for our current sum, and we'll set that off. Initialize that with a value of 0. And then here we'll go ahead and loop through, do one pass through our array. So we don't have to do the nested for loop. That would obviously make our time complexity a lot slower. We can do this in a linear time by going through the array just once. So for num in nums, what we do here is that we want to update, we want to add whatever value at our iteration to the current sum value. So we do a plus equal num, and then we also want to update our answer to be the maximum of current sum and our answer itself. So whichever is larger, the max of it will be updated to the variable that store the answer. And then finally, we want to also reset the current sum to the max of the current sum and 0. So if right here, if our current sum is a positive value that's greater than 0, then we'll go ahead and update the current sum to that. If it comes out to be a negative number, then we'll discard the entire the current sum subarray, and then just reset the current sum back to 0. All right, and then at the very end, we just go ahead and return the answer. And yeah, this right here is Kadane's algorithm. Let's go ahead and run this block of code to see if it works. And it got accepted. And then I think I already explained the time complexity of this, but I'll go ahead and do it again just to cover all my bases. So this algorithm time complexity is O of n linear time. And reason being is because we are looping through the array, the entire array just once, and within the our loop, we are doing constant time operations. So these checks right here are in constant time. So our overall time complexity is just O of n. And then our space complexity is still going to be remaining at constant time, because again we're not using any extra space in our algorithm here. So yeah, that's Kadane's algorithm. And if you still don't quite grasp this bit of code yet, let's go ahead and copy this into Python tutor website and actually see the code run and have the output visualized first. All right. So here's Python tutor, and here's our block of code that we use in the LeetCode. And now we're going to go ahead and on the right side, it's going to actually draw out our algorithm as we step through our code, and you can see it here. So right now, what we have right here is a maximum subarray function, and within this function there is a nums array, and here's our nums array. And we want to also initialize a variable to store a negative infinity number. So this is how it is represented. And then we also want to create a variable to store our current sum, setting it to the value of 0. And then now we're going to be stepping through our code. So right now we are at indices 0, and the value is -2. Right now we have to just add our current value to our current sum value. So -2 is going to be added to 0, which gives us a value of -2, and then here this block of code here is now we're going to be updating the answer value to whatever the max of the current sum and the answer. So whichever the max is between these two values, and obviously -2 is greater than -infinity, so then answer will be updated to -2. All right, and then we'll continue on with the loop, and now we add indices 1, where our current num value is 1, and then again we're going to be adding 1 to our current sum value, and then we're going to be updating answer to the max of answer and current sum. So then 1 is greater than -2, so the answer would be updated to be 1. All right, and then we'll go ahead and do update current sum to the max of the current sum and 0. So whichever is greater, and obviously 1 is greater than 0, so we're going to leave current sum as is and continue on with our loop. And then so we'll go through a few more examples here, and then now we add indices 2 with a value of -3, and then we add -3 to the current sum, which will give us a current sum of -2, and then we'll update answer to be the greater of the max of 1 or the current sum, and obviously 1 is greater than -2, so answer remains at 1. And then this block of code checks to see if current sum, set the current sum to the max of the current sum and 0, and if in this case, because our current sum is a -2, it is less than 0, so we're going to go ahead and discard that and just set current sum back to 0. And then we'll continue on with our loop here. We add indices 3, value 4, add 4 to the current sum, and then update answer between the max of answer and current sum. So answer is now going to become 4, and then check to see if current sum is set current sum to the max of current sum or 0, and 4 is greater than 0, so we'll leave that as is. And then we continue on, and we'll go through this process until we get to the very end, and we will return answer. So after we step through all of this, we're going to get a return value of 6, because that's how we saw it happen in LeetCode when we apply when we execute our code. So keep going. And there you go. We got to the end of our algorithm, and our return value is 6. So that is how this algorithm works. I hope you guys like to see this sort of format where a lot of time when we explain it in code, in LeetCode, and even in Paint, you might not be able to grasp the whole algorithm. And I think using this Python tutor website developed by a developer named Philip Go. I'm sorry if I said your last name incorrectly, but this is a very awesome website, and it's to visualize your code, and you can even get help from your peers. So definitely check out this website. I am not sponsored by Python Tutor, but it is a awesome website, and you guys should definitely use it when you guys are stuck or need some help, or you just want to understand your code a little bit more. Okay, guys, so that wraps it up for today's lesson. If you guys haven't subscribed yet, please help my channel out. I am looking to try to grow my channel, and I will be delivering or try to push out regular content on a regular basis. Hopefully one video a week or more. It depends how busy my schedule is. I do have a full-time job, and yeah, I'll see you guys in the next video. Have a good day. Bye-bye.